Uh, our next speaker in this session is Brendon McKinley. Brendon is the acting director of the product branch at the National Library of Australia. Prior to joining National Library in 2006, Brendon was a member of the founding team at the Australian National University's ePress, which is Australia's first primarily electronic academic publisher. Brendon has over 20 years of experience in developing and supporting web-based content and has held a diverse range of positions at a variety of organizations across the public and private sector, including private online education platform providers, digital marketing agencies, and universities. His discourse is headed Digital Library Technologies, Trove. He will introduce us the current scenario of the National Library of Australia's digital library platform, its Trove service, digital infrastructure of the library, and the IT strategic plan 2070 to 2020. Welcome, Brendon McKinley.
You soon run out of capacity to deal with the many billions of files in that ecosystem. So DOS layer obscures these containers for many applications. All an application needs to do for delivery is to ask the layer to return blob ID X, for example. And DOS then provides a seekable data stream. By using containers, which we use in the tar format, the file and directory count is reduced by a factor of 1,000. It's similar to a WARC file for those who have any experience with web archiving. Except in the case of DOS, the metadata is actually stored in the AmberDB layer. So DOS doesn't make any attempt to understand what it's collecting. It could be in any format. It doesn't even care if the object is for preservation or if it's a derivative for display. So this is actually a really important layer for us. It allows us to perform background and sideband actions such as integrity checking, bit level preservation, and access auditing, and many other things like gathering statistics that cannot be easily done otherwise. I won't delve further on the preservation aspects of our digital library other than to say we've integrated Preservica to varying degrees of success with some of our collection systems. In terms of discovering, our little publication would like to be available via the catalogue. The DLC catalogue app is a Java Spring Boot application that interfaces with Voyager and sends the data to the ILMS. So at regular intervals, we use Voyager as our ILMS. At regular intervals, our application polls DLC for change records and sends them to Voyager, where they are discoverable in our VUFind public catalogue. VUFind has been a long-standing component of our digital library. We're looking at the moment to enhancing our discovery layer and our ILMS. So this is what it looks like in VUFind. BIB records from Voyager are loaded into the Libraries Australia ecosystem. These records then contribute to the National Bibliographic Database. I won't dive into Libraries Australia, but it's a whole separate ecosystem that we maintain too. It's largely a legacy system. It was built over a decade ago. This is what our record looks like in Libraries Australia. So delivering. Via Resource Core and Resource Sync and a whole string of other small applications and loaders and indexes, we grab those records from Libraries Australia's CBS database and move them into our Trove index, which is based on Solr. So Trove's Solr indexes were recently consolidated. We had many, we didn't even use Solr, we had Lucene directly and queried Lucene directly. So in 2016 we consolidated our newspapers, our people, our books into one Solr database. It's based on Solr 5.1. We use Solr Cloud with Zookeeper. This has 30 shards. The index is approximately 3 terabytes and contains nearly 400 million documents. The people index still sits separately. That's our part infrastructure. And the current web archives currently sit separately as well. But the new web archiving system will be coming online shortly. Also sitting separately are the Trove API indexes. The new Web Archive index is an interesting beast for us. It's enormous. As I said, it's 9 billion documents. It includes full text of all of the documents. The index itself sits on physical machines, 4 quad hosts, 16 machines each with 256 gigabytes of RAM and 6 terabytes of storage. So we split this into 96 shards, and we have a full text index of about 30 terabytes for the Web Archive, which is about 9 billion documents. The performance of the Web Archive is reasonable. I think we can sustain about 8 queries a second, but mostly because of some complex 2-level grouping we have in the display interface. We're also in the process of implementing PageRank and some other machine learning approaches to classifying the Web Archiving content. I'll skip through some of these quite quickly. The Trove UI search application, now this is a legacy application. It's about 10 years old, and it was developed in Java, developed with RESTlets. It's very tightly coupled with the Solr layer below, and perhaps later in the session we have about what we do differently, this will be the focus of what I think we would do differently. It's inextricably bound to the Solr layer below. It's responsible for building the queries, presenting the search results, and building the islands of search results for those who are familiar with Trove. This is the Trove Search UI. And this is the metadata display layer. Skip through this, but this is the same record as delivered by our API console. Trove Delivery was the focus of the digital library infrastructure replacement project. So we built what we internally called Tarkine Delivery System. It sits alongside our newspapers delivery system and our Web Archive audio delivery systems. It provides books and journal readers, picture viewers, finding aid viewers, collection viewers, PDF viewers, EPUB viewers, interactive map index viewers, browse panels. It also provides OCR text panels. It's a Java Spring MVC application. And I'll just run through what our publication looks like being delivered. It uses the Internet Archive's book reader JavaScript library. There's the OCR full text being presented alongside. We offer renditions or downloads of this work, so the user can select a range of pages they'd like to download and the format they'd like to download. I just wanted to say one more thing. Okay, we have full text search within the document too. That's actually stored in a separate index. How am I going for time? Am I done? Okay, I won't go into web archiving then. But that's a snapshot of the technologies we have in place here at the National Library and our Trove and digital library systems. Thank you.
Thank you, Brendon. Do you have any question? A few quick one or two question. Yeah, please.
So possibly the largest chunk of information to Trove is coming from Libraries Australia.
No, actually, it's from Libraries Australia, from the NVD. It's about 30 million records.
And sometimes when we search Trove, that it shows that the result is coming from Viewfind libraries. So what is the relation between the Trove interface and the Viewfind you are using in the Libraries Australia?
Complicated. It's at the moment, Viewfind sits probably parallel as a separate discovery system. It's certainly not a delivery system. It delivers the metadata record, but in the case of a digital publication, if you've discovered in Viewfind layer, you are sent to Trove's delivery system. So the relationship is complicated, and in fact, we've just finished an audit of the issues presented to the user when they're effectively punted from our system back into our catalogue, in a lot of cases back into our contributing library systems, and it's not a cohesive experience, and I think we'll address that in the coming year.
Okay, thank you. Thank you, Brendon.